This is a key to test one makeup, and it's dealing with factoring for the most part. So, in number one, in the following problems, you wanted to factor. So, number one, you're given this polynomial x squared minus 12x plus 20. And so notice that when factoring a polynomial, keep in mind you need to look for the GCF first. And so the GCF here of those three terms is 1. So if it was something other than 1, you would go ahead and factor that out first. But it is 1 here, so I can factor this as two binomials. And remember, if it's not factorable, you would say prime. But on this test, I told you I would not give you anything that's prime. So so in factoring this, you would factor this as x minus 10 times x minus 2. And so keep in mind that at this point, you need to be able to factor these proficiently. So notice that the last sign's positive, and so that means these signs in here have to be the same. And a negative 10 times a negative 2 is a positive 20. And you always want to make sure you get that negative 12x term in the middle. So that's from your outer, which is negative 2x, and your inner, which is negative 10x, which gives us negative 12x. And x times x is x squared. So you can always check by following this out, which is what we just did. So that's the answer to number one. Number two, you had this polynomial, 3x squared minus 4x minus 4. And so again, the GCF here is 1. So we're going to go directly to two binomials. And the first term is 3x squared, so the only possibility for 3x squared is 3x and x. The last term's negative, right? So that means that these signs in here are going to be different. One's going to be positive, one's going to be negative. And then I want the last two terms to have a product of a negative 4. And so let's go ahead and use 2 and 2. And it works out to where the one with the negative sign and the one with the positive sign is this. So this has to be negative, this has to be positive. And you can always check, FOIL it out. Don't go any further without foiling this out. And so notice when you FOIL, you get 3x times x is 3x squared. The last, a positive 2 times negative 2 is a negative 4, and the outer and the inner has to give that middle term. So the outer is a negative 6x, the inner is a positive 2x, and I add them up, I get negative 4x. So that's the answer number 2. Number 3, we have in number 3. So number 3 is not factoring. So I'm going to go ahead and put that here for number 3. So number 3, all they wanted you to state was the greatest common factor of these two terms. So 20x to the fifth and 18x cubed. So that's what they want you to find there. So find the GCF of those two terms. So remember the greatest common factor of 20 and 18, so the largest factor that these two numbers, 20 and 18, have in common is 2. And in the variables, you have x's in both terms, but remember, you always use the 1 with the smallest exponent, with the smallest set of factors, and so that'll be x cubed. So the answer here is going to be 2x cubed. All right, and number 4 has to do with factoring, so I'm going to put that here. So number 4, you have 9x squared plus 6x minus 8. And so the GCF here is 1, so I'm going to go directly to two binomials. And for 9x squared, let's use 3x and x. So 3x times 3x is 9x squared. For the last, let's use 4 and 2. And it's going to turn out that the one that actually works will be where 4 goes here and 2 goes here. And always check. If you put it in the wrong order, FOIL it out and see if you get the correct answer. If you don't, try something else. All right, but it's going to work out to where this would be 3x plus 4, this factor is 3x plus 4, and this factor is 3x minus 2. Again, check. 3x times 3x is 9x squared. A negative 2 times a positive 4 is a negative 8. The outer and the inner have to give you this middle term, positive 6x. So the outer is a positive 12x, the inner is a negative 6x, and when you add them up, you get positive 6x. All right, number 5, you have 6x cubed plus 15x squared minus 8x minus 20. Now in this polynomial, notice I have 4 terms, 1, 2, 3, 4. And so the way you're going to do that is to factor by grouping. So let's go ahead and group the first two and group the last two. So when I group the first two, I can factor out the GCF of the first two is 3x squared. So I'm going to go ahead and factor out at 3x squared. And when I do that, I get 3x squared times 2x is 6x cubed. And then 3x squared times a positive 5 is 15x squared. Now in the next group, I'm going to factor out that negative sign here. So negative, and then GCF will be a negative 4 in this case. And so when I factor out a negative 4, I get negative 4 times 2x is a negative 8x, and then negative 4 times a positive 5 is a negative 20. Notice these two factors, or these two expressions I have in parentheses here, are the same. So I'm going to go ahead and factor that out. So I get 2x plus 5 times, and when I factor out the 2x plus 5, I get 3x squared minus 4. 3x squared minus 4. And there's your answer. And if you FOIL this out, you should get the original back. You will get the original back. All right, number 6, we have 56w to the 11th power plus 40w to the 6th power. So again, the first thing you need to do is find the GCF. So in this case, you'll notice that the GCF of 56 and 40 is 8. 8 goes into 56, 8 goes into 40, and that's the largest factor they have in common. And for the variables, you have 11 factors of w here, you have 6 factors of w here, so you're going to use 6 of them, smallest amount. So w to the 6, so that's your GCF. So then this becomes 8w to the 6th power times, and then 8 times 7 is 56, w to the 6th times w to the 5th. Remember, you multiply like bases, you add exponents. 6 plus 5 is 11. Plus, and then 8 times 5 is 40, and then I already factor out all of the factors here, so that's all I need to put there. So there's your answer. That's all you do. All right, number 7, we have 4x squared plus 40x plus 96. All right, now again, the GCF of those three terms is 4. 4 goes into all of these terms here, 4 into 4, 4 into 40, and 4 goes into 96. So first thing you got to do is factor out a 4. And when you do that, you're going to get 4 times x squared, 4 times 10x is 40x, and then 4 times 24 is 96. And then factor this trinomial. You need to go further, factor completely. And so when you factor this trinomial, this is easy kind because the last sign's positive, middle sign's positive. So you can get x plus 6 times x plus 4. And so the answer is 4 times x plus 6 times x plus 4. All right, so that was number 7. Now number 8, so let's look at number 8. All right, number 8, we have this problem for number 8. We have 100 m squared, so 100 m squared minus 81 n squared. So the GCF here is 1, but notice this is the difference of two squares. 181 is a perfect square, so is m squared and n squared. So I can factor this as 10m minus 9n times 10m plus 9n. All right, difference of two squares. Number 9, we have 64x cubed minus 27. All right, now this time you're dealing with the difference of two cubes. And so I know this is the difference of two cubes because I can rewrite each of those terms as some term to the third power, something to the third power, some factor to the third power. So for 64x cubed, I can rewrite this as 4x times itself 3 times. For 27, I can rewrite this as 3 times itself 3 times. And so remember, when factoring the difference of two cubes, you're going to use this formula. So f cubed minus l cubed, remember, is a binomial times a trinomial. So it'll be f minus l times f squared plus fl plus l squared. And so in this case, f is 4x and l is 3. And so then the answer becomes 4x minus 3, f minus l, 4x minus 3, times, and then you square 4x, so 4x times 4x is 16x squared, plus you multiply 4x and 3 together. 4x times 3 is 12x. And then you square, in this case, 3. So you get positive 9. And so there's your answer. Number 10, we have x squared minus 4xy minus 45 y squared. So the GCF here is 1, but you do have two variables, and so I'm going to go ahead and factor this as x. And I notice the last sign's negative, so these signs in here will be different, and you want the middle term to be negative 4xy. So when you factor this, you should get x minus 9y times x plus 5y. So notice x times x is x squared. A negative 9 times a positive 5, negative 9y times a positive 5y is a negative 45y squared. And when you do the outer, which is a positive 5xy, and the inner, which is a negative 9xy, you get negative 4xy. So there's the answer for number 10. Number 11, you have x squared minus 11x plus 28 equals 0. Now this time they want you to solve this equation. So there's a direction. So the direction says solve the equation. But you need to show the work. All right, so when solving this equation, and the direction says solve the equation by factoring, using factoring. And so when using factoring, you got to make sure that the terms on the left side are in descending order, and on the other side you have 0. So you can use the 0 factor property. So at some point, you're going to need to use a 0 factor property. And so when you do the work, what you should have done next was, first of all, notice the GCF is 1. So I'm going to go ahead and factor this as two binomials. Don't forget, you got to say equals 0, okay, because you're solving this equation. And so when you factor this, you can get x, in this case, will be x minus 7 times x minus 4. So now notice that I have two factors whose product is 0. So according to the 0 factor property, one of those has to be 0. So we're going to set each one equal to 0, just like this. And so now notice I went from a quadratic equation to two linear. And so when I solve each of those linear equations, I get x to be 7 and x to be 4. And there's your solution. So there's your work. You had to show this. You had to show the factoring equals 0, then set each one equal to 0, and solve each of those equations. So there's your solutions. So number 11, it said solve the following equation by using factoring. The same thing for 12. So for 12, when you looked at number 12, it says solve using factoring. So you had this factoring. So you had this quadratic equation, which looks like this time. It said 2x squared plus 3x equal 14. Now remember, when solving a quadratic equation by factoring, you need to make sure that 0 is on the other side. So you have to put this in standard form. So we need to subtract 14 from both sides. And so when I write it in descending order, I get 2x squared plus 3x minus 14 equals 0. And so now this looks like the same thing we're going to do here, like we did here. And so I'm going to go ahead and factor. The GCF here is 1, and it is factorable. So I get 2x, x, the last sign's negative, so these signs have to be different in here. And it turns out that it's going to be 2x plus 7 times x minus 2. Again, before you go any further, always check to make sure when you follow this out, you get this equation, this trinomial back. All right, now, so notice I went from a quadratic equation to two linear factors. I'm going to set each of those factors equal to 0, because according to the 0 factor property, when I have two or more factors whose product is 0, one of these has to be 0. So 2x plus 7 equals 0, x minus 2 equals 0. So I'll solve each of those linear equations. Over here I get 2x equal negative 7, so x is a negative 7 halves. Over here I get x to be 2. So those are solutions to number 12. So there's the work, there's your solutions. All right, now number 13, they asked you to simplify each rational expression. So simplify the rational expression. Okay, now remember, when simplifying the rational expression, and here's our problem, we had x squared plus 10x plus 24 divided by x squared minus 36. Okay, so that's our rational expression. And so when simplifying that rational expression, you got to first of all factor all the numerators and factor all the denominators. So when I factor the numerator, I get x plus 6 times x plus 4. When I factor the denominator, that's the difference of two squares. I'm going to get x plus 6 times x minus 6. Now, remember, you need to tell me how you are reducing. I need to see that you know what's being reduced. So notice the x plus 6 are have common factors, so you're gonna divide those out. You're gonna cross those out like that and put factors of ones in their place because that's what this is. X plus 6 divided by x plus 6 is 1. And so now your answer is going to be x plus 4 divided by x minus 6. So there's your answer, and there's your work. Okay? You had to show this. You had to show the factoring, and you had to show me what was being reduced. I kept informing you all about that in emails, in messages, in the lessons, in Zoom meetings, and all that. All right, you must do that. Okay, now number 13. I'm sorry, number 14. 14, same thing. You're going to simplify the rational expression. So number 14. So 14, you have, all right, so 14, simplify the rational expression. So simplify. And so the problem is this. You have 3x squared plus 5x minus 2 divided by 7x squared plus 12x minus 4. Again, notice when you simplify, the first thing you got to do is factor the numerator, factor the denominator. Both of those have a GCF of 1, so I'm going to go directly to two binomials in both cases. And when I factor the numerator, I'm going to get 3x minus 1 times x plus 2. Okay, so when you multiply this out, you get this trinomial. When I factor the denominator, I'm going to get 7x minus 2 times x plus 2. So once you factor, the next step is to reduce your common factors. You must show me what's being reduced. So you must say this, the x plus 2's divide out, you're left with factors of 1's, and so you get 3x minus 1 times 1 is 3x minus 1, 7x minus 2 times 1 is 7x minus 2. And so that's the answer to number 14. Okay, now number 15, simplify again. So you're given this rational expression. You want to simplify. You have x squared. Oops, I'm sorry. That's not what number 15 says. So let me redo that. So number 15, you have this rational expression. You have x squared minus 7x minus 18 divided by x squared minus 19x plus 90. What number 15 says is this. Number 15 says determine the values of x, the values of the variable, determine the values of the variable for which the rational expression is undefined. For which the rational expression is undefined. Okay, so you want to first of all remember that a rational expression is undefined when the denominator is 0. It doesn't matter what the numerator is the denominator. So all you need to do is look at the denominator. So that's how you deal with that. So you're trying to find out, well, where is this denominator? Where's this expression here equal to 0? So you have to set the denominator equal to 0, and then you solve this quadratic equation. So when I solve this quadratic equation, I'm going to go ahead and factor. And when I factor, I get x, what's this? It's going to be minus 10 times x minus 9 equals 0. And then I set each of those equal to 0 because the 0 factor property says when you have two or more factors whose product is 0, one of them has to be 0. So I get x minus 10 equals 0, x minus 9 equals 0. So I get x to be 10, x to be 9. So those are the values of the variable that makes this rational expression equal to 0, this rational expression undefined, because when x is 10, this denominator is 0. When x is 9, this denominator is 0, and you cannot divide by 0. And you can always check, and all you do is just check these in the denominator, because the numerator can be any number, but any number is just that the denominator cannot be 0. So notice when I do 10, 10 times 10 is 100, 19 times 10 is 190, right? So 100 minus 190 is a negative 90, negative 90 plus 9 is 0. You do the same thing with 90, you'll get 9, you'll get 0 here. Okay? All right, so those are the values of x that makes the, so we wrote this, I think, as a set, so you'd say 10 and 9. So those are the values of x for which the values of the variable, the values of x, for which the rational expression is undefined. Okay, and then finally number 16. Number 16 asks you to do this. So let me go ahead and write the problem. So 16, we had 8x squared minus 2x minus 3. And they wanted you to factor this using the AC method. All right, AC method. And remember, the AC method is sometimes called grouping. So that's where you have to rewrite this trinomial into 4 terms. Okay? And so the AC method said this. So the AC method says you want to find, you're basically going to look at the product AC. So A, remember, is a coefficient of 8 of x squared, which is 8, and C is a coefficient, is your constant, which is negative 3. So the product AC, so let me write this out. A is 8, C is negative 3, is negative 24. And you want the sum to be the middle, the coefficient of the middle term of the x term, which in this case is negative 2. So basically you're finding two numbers whose product is negative 24 and whose sum is negative 2. And so if you think about it, what would work would be a negative 6 and a positive 4, right? Because negative 6 times a positive 4 is a negative 24, and a negative 6 plus a positive 4 is a negative 2. So you're going to rewrite this middle term using those two numbers. So in other words, you're going to say this. You're going to say 8x squared minus 6x plus 4x minus 3. So you see this middle term, negative 2x, means the same thing as negative 6x plus 4x. All right? So the first thing you have to do is rewrite this as 4 terms, and then you group, and then you go from there. So from here, I can factor out a 2x. So 2x times 4x minus 3 is going to give me 8x squared minus 6x. And then here, I can factor out the GCF here is 1. So you got to say plus 1 times 4x minus 3. All right, GCF here is 1. GCF here is 2x. Now notice these two are the same, so you're going to factor out the 4x minus 3, and then you're left with 2x plus 1. So when you factor out the 4x minus 3, you're left with 2x. When you factor out the 4x minus 3 here, you're left with plus 1. And so there's your answer. That's what you get. So that's factoring using the AC method. So remember, the AC method is product sum. Product sum. Okay, so that is the, let's see, so that is the key to test 1 makeup.